Welcome to This Explainer. Today, we're taking an incredible cosmic journey. We're going to count down from those close, but frankly pretty challenging exoplanets, all the way to the ultimate Earth-like candidate, the one that's most likely to actually host alien life. You know, the universe is mind-bogglingly vast, but we've actually managed to pinpoint specific planets that have a real, legitimate shot at habitability.
Here's our roadmap for today's explainer. First, we'll look at the search for alien habitats. Then, close neighbors with hostile conditions. 3, strange oceans and multiple suns. 4, the most promising systems. 5, the ultimate Earth twin. And finally, 6, we'll ask, are we looking hard enough?
All right, Section 1, the search for alien habitats, counting down to the ultimate Earth-like exoplanet.
So, when we talk about searching for habitable zones, that Goldilocks area around a star where liquid water could theoretically exist, distance is literally our very first hurdle. Just look at this number, 70,000. Proxima Centauri b is our absolute closest exoplanet neighbor. It orbits the nearest star to our sun just 4.2 light-years away, which, sure, sounds close on a cosmic scale, right? But it would still take a spacecraft a staggering 70,000 years to get there using our current technology. And even though it sits nicely in that habitable zone, with estimated surface temps between -40 and 30 degrees Celsius, well, there is a massive catch. That catch is something called tidal locking. Scientists strongly suspect this affects Proxima Centauri b. Basically, because it orbits so close to its star, one side is permanently baked by the sun, while the other is just frozen in eternal, pitch-black night. So if life does exist out there, it could likely only survive in this super narrow twilight band right between those two extreme halves. Talk about a tough neighborhood. Moving on to Section 2, close neighbors, hostile conditions, surviving heavy gravity and violent solar flares. The crucial takeaway here is that any aliens living on these nearby worlds would have had to evolve in some pretty drastic ways just to survive. Take Proxima Centauri b again. It orbits a red dwarf, which constantly blasts massive solar flares. We're talking 60 to 100 times the radiation of our own sun's flares. Life there would probably have to hide deep underground or rely on a massively thick atmosphere just to not get fried. Then there's Gliese 581d, a super-Earth with heavy gravity. Now, if this planet actually exists, which is heavily debated in the astronomy community, aliens there would have to be built super low to the ground. They'd need to be really compact and dense just to handle the crushing gravitational pressure. Tall, spindly sci-fi aliens? Yeah, they simply wouldn't make it there. And then we have Kepler 238c. Just imagine trying to take a stroll on this world. Honestly, it would feel like trying to run through a warm, heavy ocean. It's a super-Earth with an estimated 3 to 4 times Earth's mass. It sits right on the inner edge of its habitable zone, creating what would basically feel like a permanent, intense tropical heat wave. When you combine that heat with the heavy gravity and a super-dense atmosphere, any life here would need some absolutely incredible physical tolerance just to exist day to day.
That brings us to Section 3, strange oceans and multiple suns, redefining what a habitable world looks like.
Once we look past those really harsh environments, things start getting beautifully strange. It really expands our imagination of what an alien homeworld could actually look like. Just picture looking up at the sky and seeing 3 distinct suns. Well, that is the reality for Gliese 667cc, located about 23 light-years away. Now, the gravitational interactions and the radiation from multiple stars definitely make its long-term atmospheric stability a bit complicated, especially since one companion star is a flare-prone red dwarf. But its thermal range makes it a very strong candidate for life. It sits right near the center of its habitable zone, taking in about 90% of the energy Earth gets. So temperature-wise, it's actually a surprisingly comfortable fit. This brings us to the Kepler 62 system, where we find potential ocean worlds. Kepler 62e is modeled as being covered entirely by a global ocean, literally no exposed continents at all, which is a fascinating prospect, right? I mean, Earth's oceans are teeming with life, even out in the deep where there's no land in sight. Its outer sibling, Kepler 62f, receives a bit less energy and would need a pretty strong carbon dioxide greenhouse effect to avoid completely freezing over. But it could totally support liquid water seasonally, or maybe near its equator. Both of these are incredibly credible candidates for harboring aquatic alien life. All right, let's dive into Section 4, the most promising systems: stable atmospheres and quiet stars. When we compare the numbers, both Kepler 186f and TRAPPIST-1e receive significantly less energy than Earth does. Kepler 186f gets only about a third of our solar energy, making it a pretty chilly world. TRAPPIST-1e gets roughly 66%. What this means is that both planets would rely heavily on greenhouse gases to trap heat and sustain liquid water. But here's the exciting part. With the right atmosphere, they go from being frozen rocks to highly hospitable candidates.
Let's take a closer look at the TRAPPIST-1 system, because this is arguably the most exciting group of planets we've ever discovered. Out of its 7 planets, 3 of them fall directly in the habitable zone. And TRAPPIST-1e is the absolute standout among them. It's almost identically sized to Earth. Now, it orbits its star in just 6 days, so it's highly likely to be tidally locked. But climate models suggest that even a moderate atmosphere could create these massive heat-redistributing winds, which would bring those warmer daytime temperatures comfortably around to the dark side of the planet. Adding to our list of elite candidates is LHS 1140b. This one is a genuinely solid contender for alien life, primarily because its host star is so remarkably quiet. Unlike the violent red dwarf we saw with Proxima Centauri, this star isn't blasting out those atmosphere-stripping flares, and that drastically improves the chances of LHS 1140b holding onto a stable atmosphere for billions of years. Receiving 43% of Earth's solar energy, it's a bit on the colder side, but it could very well be covered by a large ocean. And the best part? It's currently being actively studied by the James Webb Space Telescope.
Now we arrive at Section 5, the ultimate Earth twin, the crown jewel of exoplanets.
We have officially reached the crown jewel of exoplanets. This is the planet that scientists would probably want a telescope pointed at permanently. Take a look at this metric, 0.84. That is Kepler 442b's Earth Similarity Index out of a perfect 1.0. This metric basically rates how closely a planet matches Earth's conditions, and scoring an 0.84 makes it an extremely likely place for aliens to exist.
Located roughly 1,206 light-years away, this planet sits so perfectly in its habitable zone that the conditions are remarkably close to ideal. It's about 1.3 times the size of Earth, which means the gravity would feel very familiar to us, and it receives a wonderful 70% of Earth's solar energy. If it has a rocky surface and a decent atmosphere, and honestly both of those seem highly plausible based on the data, it quite literally checks almost every single box for habitability. Out of everything we've looked at today, guys, this is the one.
Finally, Section 6. Are we looking hard enough? Preparing for what's out there. We've journeyed all the way from hostile, flare-blasted rocks to beautiful global oceans, right down to near-perfect Earth twins. And this proves one thing. The universe is incredibly rich with potential homes for life. So I want to leave you with this provocative thought to ponder. If a world like Kepler 442b checks every single box, what happens when our technology finally lets us peer directly into its atmosphere? Are we actually ready for what we might find? Because based on the data in this explainer, the possibility of alien life isn't just science fiction anymore. It's mathematically and astronomically very real. Keep looking up and keep asking questions.